The three members of the Apollo 12 crew were Mission Commander Charles Conrad, Command Module Pilot Richard Gordon, and Alan Bean, the Lunar Module Pilot. The astronaut crew, three officers of the United States Navy. The crew likened their vehicles to sailing ships. The call signs selected for their spacecraft, Yankee Clipper and Intrepid. The mission emblem carried out the motif.
Their target, the site of Surveyor 3. April 19, 1967, Surveyor 3 landed on the moon in a crater of Oceanus Procellarum, the ocean of storms.
Well, there are two possibilities, and the first one is that we do land close enough that it's really right at hand. When I say right at hand, within 300 or 400 feet. Then there's the possibility that for some reason or another, it is close enough for us to walk to, but it's not readily at hand. It's, say, 2,000, 2,500 feet. In the latter case, we would plan our geology traverse so that at some point in that traverse, we would wind up at the Surveyor. And in other words, that's the most efficient way to utilize the time, and just walking to it would be to do this documented sample en route to the Surveyor and back from it. And of course, the other is we can run a traverse anywhere we want to and come back to the spacecraft, leave the rocks, and then just wander over to the Surveyor, which says we landed very, very close to it. In either event, when we get there, aside from the photographic information that we should bring back about the Surveyor, and Al is going to take the photographs, we have 4 items which we're going to try and retrieve off the Surveyor. This glass has been sitting out for 31 months exposed to micrometeorites, and we can bring the glass back for him to examine. And the other thing that would be interesting would be a polished aluminum tube, which is relatively easy to cut off, which also has been exposed both to micrometeorites and the solar wind. And then there is the TV camera that is mounted on there that has some cabling to it. Now, they would like us to cut a sample of the cable off. And the last thing is the TV camera, which is a multitude of different kinds of parts. By bringing back that TV camera for analysis, the engineers would get a very good handle on the effects of long-duration exposure to the space environment on materials, and would crank this into, obviously, later designs of both unmanned and manned satellites that you want to stay up and operate for a long time. So these are the bonus benefits that we'd get by making a spot landing next to the Surveyor.
Well, I think by and large it's fairly simple to describe those. It's basically the same as Mike's was. We jokingly, I guess maybe not jokingly, call ourselves the bus drivers. Pete and Al get in, I say leave the driving to me, and away we go. It is a challenge in its own right. I am basically responsible, or have that responsibility after the launch and after the insertion in the translunar coast, of being cognizant of the command module itself. Obviously they're there and they're with me and they know a great deal about it. But I think Pete has genuinely left that responsibility with me, and he's counted on me to fulfill that task of making sure that the command module does its job. In other words, it gets them to lunar orbit. It fulfills its requirement for getting the lunar module ready. It stands by in all cases to rescue the LEM in the event that that has to be done, and of course we all hope that it doesn't. That's a formidable task in itself. Being responsible for the rendezvous itself after their lunar surface activities are completed. And then, of course, coming back home, the navigation that must be done, and the entry itself. These are the things that I'm responsible for.
Well, now, Dick, after the surface activities completed and Pete and Al are safely back inside your command ship, the flight plan calls for the three of you to spend an extra day in lunar orbit to photograph future Apollo landing sites. Do you consider this a major part of the Apollo 12 mission?
It certainly is, and I think it's a very vital aspect of this flight. It's an added feature, you might say, of our flight, and if you really look at it, it's exactly what Apollo 8 did on their flight. We've tacked that on as an addition to ours. But that's an indication, I think, only of the amount of activity we'll be doing. And it is all basically surveying and basically photography for future Apollo flights. I think to make the future of Apollo interesting, captivating, and certainly scientifically valuable, we must go to the areas on the lunar surface that are the most interesting significantly as far as geology is concerned.
Al, you and Pete Conrad are scheduled to spend 2 separate 3-hour periods out on the lunar surface. During the first EVA, plans call for deployment of 5 scientific experiments onto the surface: a seismometer to detect moonquakes and other instruments to measure the lunar environment. This package of experiments is nicknamed ALSEP. Could you tell us maybe a little bit about this?
Okay, as you know, the ALSEP, Apollo Lunar Surface Experiment Package, is a combination of 4 or 5. I use that word because one of them is a smaller and attached to another experiment that we're going to leave on the moon for forever. But it has a guaranteed lifetime of about a year, so it'll be sending back good scientific information for a year. We expect that it will operate then for another year just as well, even though it doesn't have to, and then after that we probably won't be using it. But our job then is to put this package out on the surface where it will be best located to gain the information that it needs, that it is able to gather, and in a position where it won't be disturbed when we actually ascend from the lunar surface.
On September 8th, at the Kennedy Space Center, Apollo 12 began the first step on its journey to the moon, the slow rollout from the vehicle assembly building to the launch pad. At the Kennedy Space Center and at the Manned Spacecraft Center, the crews of Apollo 12 were training for all aspects of their missions, including command and lunar module flight simulations, lunar surface operations, and acclimation to lunar gravity conditions.
The 2 astronauts assigned to the landing mission rehearsed the lunar work many times on Earth. The astronauts were scheduled to leave their spacecraft twice while on the moon. During the first period of activity, they would set up the Apollo Lunar Surface Experiments package, conduct extensive photographic assignments, and collect soil samples near the spacecraft. During the second period, they were to locate the unmanned Surveyor 3 spacecraft. The astronauts were to remove several parts from the Surveyor, including its television camera, and return them to Earth for investigation. The final countdown of the Apollo 12 space vehicle was begun on Friday, November 7th. On November 10th, a leak was discovered in a hydrogen fuel tank in the spacecraft service module. The launch team worked around the clock to replace the faulty tank as the countdown continued. If they had not been successful, the Apollo 12 liftoff would have been postponed until the next launch window in December. Rain showers and overcast skies were forecast for launch day, November 14, 1969. Since the wind was moderate and the ceilings were above minimum, the countdown continued.
This is Apollo Saturn Launch Control. We're in our built-in hold, T-minus 3 hours, 30 minutes, and holding. We've now 13 minutes into the hold. The total duration of this hold, 1 hour. The crew is now sitting down to breakfast. They have some visitors for breakfast this morning. Their menu is the normal astronaut fare of orange juice, steak, eggs, coffee, and toast. Joining the astronauts for breakfast, and we'll have a final report on this a little later on when we confirm all the visitors, but joining the astronauts for breakfast is Tom Stafford, the Apollo 10 commander, who is now chief of the astronaut office, and Tom, in fact, awoke the astronauts this morning. Deke Slayton, who is director of flight crew operations. Astronaut Jim Irwin, who is one of the backup pilots. Mr. Chuck Tringali, who is director of the crew training for the Apollo 12 mission. astronaut Paul Weitz. Paul Weitz is the backup, actually the support lunar module pilot, and also acts as Stoney, or the capsule communicator, here in the firing room during the countdown. And an additional member of the guests for breakfast is Jim McDivitt. Jim McDivitt, of course, the commander of the Apollo 9 mission, but now acting in the capacity of Apollo program director at the Manned Spacecraft Center. So the crew sitting down for breakfast while we're in the hold. All our propellants are stable with the launch vehicle. We are go as far as our launch time of 11:22 a.m. Eastern Standard Time is concerned. Weather conditions will be acceptable for launch under the latest forecast. T-minus 3 hours, 30 minutes and holding in a built-in hold. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. T-minus 3 hours, 21 minutes, 26 seconds and counting. We're on time as far as our count is concerned for Apollo 12. The prime crew for the mission, astronauts Pete Conrad, Dick Gordon, and Alan Bean, finishing up their suit checks in the suit room nearby their crew quarters here at the Kennedy Space Center. We expect them to be departing from the crew quarters about 10 minutes from this time to start a trip of about 9 miles that will wind up on the 320-foot level at Complex 39, the location of their Apollo 12 spacecraft. Astronaut Al Worden, the backup command module pilot, is in the Apollo 12 spacecraft at this time, busy with preliminary work and preparations, checking out the various switches in preparation for the arrival of the flight crew. We are go at 3 hours, 20 minutes, 37 seconds and counting. This is Launch Control. Apollo Saturn Launch Control, 3 hours, 12 minutes and counting. The Apollo 12 crew now departing the crew quarters, boarding their transfer van, ready for the 9-mile trip to the launch pad. We give about 18 minutes for the crew to go from their crew quarters to the launch pad, where they'll board their Apollo 12 spacecraft at the 320-foot level. We had it logged at 10 minutes past the hour when the Apollo 12 crew members, astronauts Pete Conrad, Dick Gordon, and Alan Bean, departed from the quarters and boarded their van. Although it appears not to be raining at the crew quarters area, we appear to have a pretty good rainstorm going on in the vicinity of the launch pad at this time. However, it is not interfering with any of our operations in the count. The weather forecast is still go for launch as far as our 11:22 a.m. Eastern Standard Time T0 is concerned. The crew now aboard the transfer van. We expect they will be departing shortly for the trip to the pad.
The astronauts arrived at the launch pad at 8:30 a.m. and proceeded to the top of the launch tower.
The first astronaut aboard will be the commander, astronaut Pete Conrad, who sits in the left-hand seat. He will be followed by the lunar module pilot, Alan Bean, who sits in the right-hand seat. While these first two crewmen are going aboard, the third member of the crew, astronaut Dick Gordon, will remain in the elevator at the 320-foot level. He will be in the company of a suit technician, and as the progress of the second astronaut, Alan Bean, is accomplished, as he's brought aboard, Dick Gordon will be called across the swing arm and will be the third member of the crew to come aboard. The transfer van now departing from the crew quarters at the Manned Spacecraft Operations Building here at the Kennedy Space Center on the start of the trip to the launch pad. We're at 3 hours, 10 minutes, 20 seconds and counting. We're go on the Apollo 12 countdown at this time. This is Kennedy Launch Control.
They crossed the access arm and entered the White Room. The closeout crew assisted each of the astronauts in entering the command module, which would be their primary base of operations during their 10-day lunar mission.
This is Apollo Saturn Launch Control, T-minus 2 hours, 48 minutes, 56 seconds and counting. The astronauts have arrived in the White Room. That is the spacecraft commander, Pete Conrad, and the lunar module pilot, Alan Bean. The third member of the crew, astronaut Dick Gordon, will stand by in an elevator located on the mobile launcher at the 320-foot level. He is in the company of a suit technician and will be called across the swing arm after his two colleagues go aboard. The spacecraft commander, Pete Conrad, now boarding the spacecraft. He sits in the left-hand seat. We have him over the sill at 33 minutes past the hour. 8:33 a.m. Eastern Standard Time, and Pete Conrad is aboard the Apollo 12 spacecraft. Launch control, the spacecraft commander, astronaut Pete Conrad, now fitted snugly into his couch on the left-hand seat of the Apollo 12 spacecraft, and the space suit technician and backup command module pilot Al Worden now giving astronaut Alan Bean a hand in checking him out. In each case, as an astronaut is brought in to the spacecraft, he goes through the same sequence, that is to hook up a communications cable, then actually hook the astronaut and his pressurized garment into the suit circuit system of the spacecraft to bring the oxygen flow to the suit. We expect that the spacecraft test conductor, Skip Chauvin, will be calling the third member of the crew, Dick Gordon, to come across the swing arm shortly. We'll be standing by. We appear to be right on time as far as our procedures are concerned. Here in the firing room, the crew continuing to monitor the status of the Saturn V launch vehicle as we continue with crew ingress. This is Apollo Saturn Launch Control, T-minus 2 hours, 28 minutes, 55 seconds and counting. Still go with Apollo 12 at this time. At the 320-foot level at Launch Pad A, where the hatch for the Apollo 12 spacecraft is located, we now have the third member of the crew aboard. Dick Gordon, a command module pilot who sits in the middle seat of the spacecraft, came aboard the spacecraft at 46 minutes past the hour. We boarded all three astronauts in a span of about 13 minutes. All still going well with the count. Weather is go, and we're still aiming toward our planned T0 at 11:22 a.m. Eastern Standard Time.
The President of the United States, Richard Nixon, came to the spaceport for the Apollo 12 launch. This was the first time a president in office witnessed the liftoff of a manned space vehicle. Despite continuing showers, the president and his family joined other guests at the viewing stand and remained there throughout the launch activities. Vice President Spiro Agnew watched the countdown from the Launch Control Center. Rocco Petrone, the new Apollo program director, and Dr. George Miller, head of the manned spaceflight program, were also present in the firing room. With a continuous check on local weather, the countdown moved along with no unscheduled holds, under the direction of Dr. Kurt Debus and launch director Walter Caprian. As with the 6 previous Apollo Saturn V launches, the countdown reached ignition precisely on schedule.
This is Apollo Saturn Launch Control, T-minus 1 hour, 19 minutes, 55 seconds and counting. Still proceeding with the Apollo 12 countdown on time at this time. We're aiming toward our projected T0 at 11:22 a.m. Eastern Standard Time. Astronaut Pete Conrad, the spacecraft commander, is now working with the spacecraft test conductor, Skip Chauvin, in preparation for some guidance and control checks that'll be coming up in the spacecraft shortly. This is Apollo Saturn Launch Control, T-minus 6 minutes, 30 seconds and counting. We're still proceeding satisfactorily with our countdown at this time. 17 seconds, swing arm back. We have guidance internal. 10, 9, 8, ignition sequence start. 6, 5, 4.
Liftoff took place at 11:22 a.m. Eastern Standard Time.
Liftoff. We have liftoff, 11:22 a.m. Eastern Standard Time. Pete Conrad reports that your program is in. Clear.
I got a pitch and a roll program, and this baby is really going. Man, is it?
Pete Conrad reporting the roll and pitch
That's a lovely
program to put
liftoff.
Apollo
That's
12
not
on the
bad at
proper
all.
course.
Everything's looking great. Sky's getting lighter. Okay.
Altitude at 1/2 mile.
30 seconds. Looks good. Oh, wait. Cylinder beat. What the hell was that?
At T plus 36 seconds, communications were momentarily lost with the Apollo command module. This was attributed to a discharge of static electricity generated by the space vehicle as it rose through the rain and clouds.
All the fuel cells. I just got the platform. All lunar got to GDC. Yeah. Okay, we just lost the platform, gang. I don't know what happened here. We had everything in the world drop out. I can't, there's nothing I can tell wrong, Pete. I got 3 fuel cell lights, an AC bus light, a fuel cell disconnect, AC bus overload, 1 and 2, main bus A and B out.
Despite the brief electric failure in the spacecraft, the 3 stages of the Saturn V operated flawlessly to place Apollo 12 into near-circular parking orbit above the Earth.
We've had a couple of cardiac arrests down here too, Pete.
Hey, I'll tell you one thing, it's a first-class ride, Houston.
You got a go orbit, you're looking good.
During 2 revolutions, the spacecraft's computer was updated and all instruments checked for any damage caused by the power failure.
Time for commitment neared. The burn to send Apollo 12 to the moon. Translunar injection, TLI.
Over Australia, Mission Control gave go for translunar injection, and the Saturn's 3rd stage was reignited to boost Apollo 12 into a lunar trajectory.
Apollo 12, Houston, the good word is you're go for TLI.
Hoopy-doo, we're ready. We didn't expect anything else.
We didn't train for anything else, Pete.
You better believe it.
We have data and thrust is go. Burn looks good.
With engine cut off, Apollo 12 was on its way to the moon.
400 miles above Earth, the Apollo Command Service module separated, turned around, and maneuvered into position to dock with the lunar module.
Really, on this one, it's kind of an interesting one. There's a slop panel that we happen to see flying away from the booster. The west coast of North America, coming down through Mexico, Yucatan Peninsula into South America in this area. It's the first one we were able to take after transposition and just prior to docking with the LEM and the S-4B.
Apollo 12 moving into dock with the lunar module.
Hello there, Intrepid. 12, Houston, black and white is spectacular, and the color is really pretty good, too. Apollo 12, Houston, the camera's cutting off about half of Intrepid now.
This is Dick's
That's the best we could do for
docking,
next to it.
which he did a great job on. If you look, you'll see the target that we have on the LEM that allows us to line the spacecraft up and dock without any cross-axis velocity or attitude dispersion. There's a probe shadow going into the LEM right there.
You're looking right in the LEM overhead window right now. Stick course. Roger, Al, and the color is really great now. I think we just saw you grab it. We're on the way in right now.
Docking was completed precisely as planned.
We got a hard dock, Houston. She looks good. Both A and B are gray. All latches made. Roger, Pete. Looks good.
The lunar module was then removed from the 3rd stage of the Saturn V.
Oh, there's the S-4B, and I can see it bending.
Roger, 12. When you're well clear and you're ready for us, let us know and we'll start the maneuver to the evasive attitude. Haulage motors are on.
Yeah, we can see it starting to move now, Houston. Yeah, the motor's firing.
Roger. Hey, Red Baron, where's your scarf?
Well, I tell you, I think I forgot it during that boost phase. We ought to talk to you about all that good happening. That's a terrible way to break Al Bean into spaceflight, I'll tell you. All Al Bean kept saying was, there's power on the buses, there's power on the buses. And every light on the right-hand side was lit. I kept thinking, why is he saying that to me?
That's beautiful.
I said, Al, there's so many lights on, I can't read them all to you. See, he's totally recovered from launch. See that?
Oh, it looks beautiful. That's a nice looking hat you're wearing, Al.
We got three of them just alike in here. We got something else for you, too.
To ensure that the electrical systems of the lunar module had not been affected during launch, the crew entered the lunar spacecraft ahead of time to check the systems. All results were positive.
I think you can get an appreciation for how fast we were leaving. This was not too much later, but we were leaving the good Earth, and we readily recognized that we're on our way. There's a whole series of these pictures, and I think the timing on this one, you can notice right now that we're already into the phase where you might call it a half Earth, and this is as much as we ever saw of it during the flight. It's just a little bit later, and you can already see it starting to form into a crescent as far as our view of the Earth. Hey, we're not going home, we're just going away from it more and more.
31 hours after liftoff, the astronauts fired the spacecraft's main engine to make a course transfer.
10, 9, 8, 7, 6, 5, flashing 99, throw, 2, 1, ignition, thrust, ball valve, okay, other ball valves, 3, 4, 5, 6, 7, 8, 9, shut down, all ball valves off, the pressures are okay. B banks off, A banks off, very good. What's the gimbal? Gimbal butters. Okay, yacht 2 is off.
The engine burn moved Apollo 12 into a hybrid trajectory. The maneuver committed a manned spacecraft for the first time to a non-free return trajectory rather than looping the moon for an automatic free return to Earth. The astronauts had the capability to move back into a free return trajectory by firing either the main engine or the lunar module descent propulsion engine should the need arise. The hybrid trajectory permitted a saving of fuel and allowed the lunar module to land under optimum lighting conditions.
Apollo Control Houston, 31 hours, 3 minutes down to the flight Apollo 12. MCC-2, the burn was some 9 seconds in duration. A preliminary evaluation following this burn would put Apollo 12's point of closest approach to the moon at 64 nautical miles.
Okay, 12, you guys are looking real fine. That was a nice burn.
Okay, as you can see, Dick's up there in the tunnel, and he's opening the vent valve now, and he's starting to pressurize the LEM.
We have a good picture of the hatch.
All right, while Dick's doing that, I'll go up and get the drogue.
Okay, 12, the lighting in the tunnel looks pretty good now.
Okay, and if you'll hold it just a minute, I'll get the window shades down in the LEM here. We're putting these CSM hoses down inside the LEM. Since there's no ventilation in there now, we just lay them around down there where we're going to be working with the LEM. And it makes it real nice for cooling and gives you some clean air down in there. Without them, it gets a little stale after a while. Pretty easy. Float on up. Only problem is when you get in here, we're going to be upside down, and then you got to turn around sideways. Happy the camera. Which way is right side up?
12 Houston, we had a pretty good view of your ECS module there, and now we're getting a good view of the main panels. Upside down.
Okay, what we've got on this side, Jerry, is what we call a left-hand side storage compartment.
And it's pretty unique in that it's made out of beta cloth, and for these snaps, you can see we can remove it. So what we do after the first EVA, we put a lot of our things that we don't need anymore inside these bags, and then we can put them outside on the lunar surface. And after the second EVA, we can put some other things in this other, or the back end side of this storage compartment, and then put it out on the lunar surface also. So we end up being able to very tidily put some of our gear on the outside of the spacecraft, so it'll be a lot lighter when we get ready to leave the lunar surface, which is handy since you can bring back more rocks and what have you. Roger. Jerry, I'm showing you a picture of the instrument panel right now, but what I'm more interested in, on my monitor, I can see some dust particles. Maybe you can see them down there on the TV. I think that's pretty good resolution. That's affirmative, Pete. To be floating in the sunlight. They just happen to be floating in the sunlight that's in here. Of course, there is a little bit of, it's very light dust, but it looks big on the TV screen because the sun is illuminating it. But I'm going to try to show you without bothering the camera. Yeah, but we don't need it since I've got it once, see? 12, Houston, what's the configuration of your suit ISO valves now? We opened and closed them for the checklist. Okay, what happens is Pete stands right behind those scribe marks. You can see right at the top there's where the horizontal line is, that's 0 degrees, then there's a 10 down, 20 down, 30 and 40 and on down. Right at the top then, left and right, there's also some angular marks. As we proceed in the descent, and we pitch over where the lunar surface is visible about 7,000 feet, Pete's going to be looking out through the window at those marks. I'll be reading from the computer, and the computer will say where it's taking us to land relative to those marks. For example, probably the first thing you'll hear me say is 42 degrees. So Pete will look out at the 42 degree mark, and he'll see if that's the Surveyor crater. We've spent a lot of time learning which crater the Surveyor's in, and a lot of the more interesting craters around there, more easily identifiable craters. You look out and see if the crater's in the right place, if the 42 degree mark's in the right place. If it is, then we'll just continue on the present trajectory. If not, he could use his control stick and put a certain number of inputs in to change the direction we're headed. For example, if he saw it at 40 degrees instead of 42, saw the crater we wanted, he could pitch down a couple or pitch up a couple, depending on what he wanted to do. If he saw it at 40, he'd pitch down a couple of lifts, a couple of hits with a stick, and hopefully very shortly the computer would notice this and start heading for the 40 degree point. I'd continue reading the numbers, and he'd continue to monitor all the way down. When we got down to a low altitude then, Pete would be in a good position for Pete to take over manually and land next to the point we're headed for. This is called the LPD, or Landing Point Designator. It allows the commander to keep up with where the computer thinks it should land, and then tell it to land at a different place if he feels it should. Very good travel log, gang. We're going to start to button her up and open. All right, Dick. Hey, Pete, we can, you want to put that up and then bring that camera in here, and I will set the camera over to you right. Take a look at the Earth and the Moon. Okay, here. Okay. Oh, I know it's been said before, but this is a really spectacular sight. It's still open. Did you wipe the seal yet? Good. I got to finish it in just a minute. Okay, I was going to lift this hatch up to you.
Then, on November 17th, they prepared for orbit around the moon.
Our motion to the left is not as apparent as our motion towards the moon, and therefore we have the decided impression that we're going right into the center of that baby right now.
The spacecraft's main engine was fired twice to slow Apollo 12 and place it into the desired 62 by 75 mile orbit above the moon.
We're beginning to go into darkness at this time.
Roger, 12.
Matter of fact, we're there.
Apollo 12, Houston, you're go for LOI.
Roger, Houston, go for LOI. Burn checklist is complete to minus 6 minutes, and we're holding a dead point.
LOI, Lunar Orbit Insertion, the burn of the spacecraft rocket engine that would place Apollo 12 into orbit around the moon. With this burn occurring behind the moon, there would be no communications with the spacecraft until it came over the lunar horizon. The command module, Yankee Clipper, the lunar module, Intrepid.
Apollo 12, Houston.
Hello, Houston. Yankee Clipper with Intrepid in tow has arrived on time. I guess like everybody else that just arrived, all three of us are plastered to the windows looking.
During the first lunar orbit, good quality television coverage was received with an excellent description of the lunar features by the crew.
We're going to move off the straight wall now, Houston, and look down at a crater. I don't have my chart here, so I don't know the name of it, but it's got extremely well-defined terraced walls. It's got a nice central peak in the middle, and let me see if I can get it better for you. There it is.
Oh, Raj, we have a
And
good
it
one
also
there,
has a nice crack right down at the bottom.
Raj, we can
That's
see
a
that.
pretty impressive looking crater. We're in the Terra now, and you can tell that the ground is much more hummocky, quite a bit rougher than the Mare, which we're getting ready to approach in a few moments. Here's another one with a good central peak. In fact, this is one of the highest central peaks that... That's a hard one to show because the radar antenna of the limb is partially eclipsing it. Can you see that central peak there?
That's a firm word.
High cone.
We're getting it good.
The rim itself. Then I'll go back and give you the horizon because that's one of the most impressive things right here. Take a look at those mountains.
We have them.
I don't know, go 5 degrees from the Terminator.
Hello, 12, Houston, you just passed over 5-degree sun angle on the surface.
Okay, that's what I was just trying to look at here and see what I could see.
The lunar landing maneuver began on the 4th day of the mission.
Pete Conrad and Alan Bean entered the lunar module, leaving Dick Gordon in the command module.
In order to avoid any minor velocity changes, a soft undocking of the two spacecraft was initiated. Lunar module power was not used to separate the two spacecraft as in previous missions. This was but one of the procedures followed by the crew to improve navigational accuracy in an attempt to achieve a pinpoint landing on the predetermined lunar landing site.
Back off, Dick.
Now the Intrepid and Yankee Clipper undocked and separated, preparatory to Intrepid's descent and landing on the moon.
There he goes. I just wanted to wait there and let that damp, Pete. Okay, I got minus... I got -1 and nothing, so forget it.
Intrepid, Houston, looks good.
How's the tube, Jerry?
Real good, Dick, real good.
I think this is one of the best 16-millimeter pictures I've ever seen that Dick took of Intrepid leaving. We've done our separation and we're waiting for, we've done our undocking and we're waiting for Dick to separate and leave us so that we get over on the night side and do our first alignment prior to the descent orbit injection burn.
Roger, your LEM gyro torque angles, X minus 0.00045. Y is minus 0.0035. Z is minus 0.00092. Over.
The first time I looked at this movie, it looked so unreal to me. I thought if I saw that in a Hollywood movie, I'd say it was a fake. But I was there, and so were Dick and Al, and we'll all vouch for the real thing here. As you can see, the way we undocked and hold inertial attitude, we are coming around to the local vertical here where we were looking at each other with the moon dropping down in the background, just coming up for Dick to do his SEP burn.
Houston, you going to try those primary servo electronics?
You can see the mountains. The terrain, of course, as you know, is quite rugged.
How's it looking? Looking good and solid now. Clipper, Houston, you can terminate every G now. It's done, it's done.
Several minutes later, Command Module pilot Gordon fired the small engines to turn his spacecraft and gently move away from the lunar module. The Apollo 12 astronauts had previously elected to use the call sign Intrepid for the lunar module and Yankee Clipper for the command module. 59 minutes after undocking, Conrad fired Intrepid's descent engine, which placed the lunar module into an orbit with a low point of 50,000 feet above the moon.
As with the orbit insertion burn, the burn to begin descent was made behind the moon. Mission Control again contacted Intrepid as it came over the horizon.
Intrepid, Houston, how do you read?
Hello, Houston Intrepid. Roger, we read you loud and clear. We had a great DOI burn. And we just watched the first Earthrise, which was fantastic.
This, of course, is a famous view. Apollo 8 started the trend, and it seems that everybody that goes to the moon has to get their particular picture of Earthrise, if you will. And once again, I think the unusual one about this picture is the shape of the Earth, or the amount of the Earth that we can see. It now is certainly becoming a crescent.
Yeah, let me make a comment on this picture. In the lower right-hand corner, you'll see a thruster. That's a LEM RCS thruster, and I guess I made a statement on the lunar surface which I am going to live to regret. The camera magazine I left out there had no pictures on it whatsoever. I thought I had left the magazine out that had these pictures on them, but these are the pictures that I was referring to, and that magazine was a spare magazine, and we had thought that we'd taken our in-flight LEM pictures with it, and we hadn't, so we didn't lose any pictures at all on the lunar surface. And Al took this picture from the right-hand window of the LEM, and I was very happy to see him show up because I thought we'd left a few in-flight pictures up there.
The Surveyor 3 target was located in the middle of 5 craters arranged like a snowman. The upper crater, called Head Crater, the body, called Surveyor Crater. Surveyor 3 is located in this crater. The object, to land as close as possible to Surveyor Crater. Then at 50,000 feet, Intrepid's engine fired and began the landing sequence.
Unlike the Apollo 11 mission, Apollo 12 approached the landing site in a windows-up attitude for continuous updating of landing radar data and for better communications.
Okay, we're out of 19,000 feet. I got some kind of a horizon out there. I got some craters too, but I don't know where I am yet. Not sure. Coming through 7. Okay, P60, P64, P. P64. That's it, there's LPD.
Roger, copy, P64.
6,000 update. Hey, there it is.
Right up in this corner, we've just pitched over, and you're going to see the snowman. He's right there. That's the Surveyor Crater. And I can't speak highly enough for the months of work people put into targeting taking out the errors that Neil had.
We're passing 3,500. Coming down at about 99 feet a second. You're looking good. Got 15% fuel. I'll reset my watch. Okay. Go for landing.
Just started my first redesignation to the right there because I thought I was going to land right in the crater.
That's so fantastic, I can't believe it. You're at 2,000 feet. How far? The boys on the ground do okay. 1,800 feet up, 39 degrees. You got 94 seconds of LPD time left. Okay, I'll move forward a little bit. 38 degrees, 36 degrees. You're 1,200 feet, Pete. Okay, 1,000 feet coming down at 30. You're looking good. Got 14% fuel. Looks good out there, babe. Looks good. 32 degrees. You're at 800 feet. 33 degrees. You're at 680 feet. 33 degrees. 600 feet. Antenna's okay. 35 degrees. You're 530 feet. You're 530. 471. You are all right. 426. I got it. 400. You're in G66 feet. Okay. G66. Okay. Yeah, I got to get over 330 feet coming down at 4.
That's Surveyor Crater right there. My original landing site is right here, and you can see the ridge. Prior to the flight, the geologists had me pretty well convinced that it was not going to be a suitable place to land. And this turned out to be the case, and you'll see it very quickly here, that right over the ridge is where I wanted to land, and the more we come up on it, the more you can see that it's full of craters. I didn't like it, and I picked a spot right over here.
10% fuel.
We're kind of flying around the crater now to the right, and then I translate back to the left, and this camera is pointing straight down the landing gear pad right here. And it's not quite the pilot's view. Got the translation pretty well killed off, and as you can see, we're seeing the first dust.
You got 9%, 8%. You're looking okay. 96 feet coming down at 6. Slow down the descent rate. 80 feet coming down at 4. You're looking good. 70 feet. Looking real good. 63 feet. 60 feet coming down at 3. 50 feet coming down. Watch for the dust. 46. Low level. 42 feet. Coming down at 3. Coming down at 2. Okay. Start the clock.
My impression was I took over a little bit higher than the data showed, but right here we're in the neighborhood of 75 feet, and we're picking up more and more dust, and we finally lose the landing area completely beneath us in the dust.
Hang in there. 30 seconds. 18 feet. Coming down at 2. He's got it made. Come on in there. 24 feet.
You'll also see engine shut down and the dust leave. Right there was a dust cloud, and it left as we did get a in-flight shutdown of the engine at about 4 feet in the air.
Command override off. Yep. Okie dokie. I'll cycle the main shutoff valve. Okay. Bus feed closed. You get both regs closed, Dave. The regs are closed. Good landing. Pete, outstanding, man. After arm on. Beautiful. He's got set.
Touchdown occurred at 1:54 a.m. Eastern Standard Time on the 19th of November at the predicted landing site within 600 feet of the Surveyor spacecraft.
Okay. The good thing we leveled off high and came down because I sure couldn't see what was underneath us once I got into that dust. It's a nice place to land. Look at those boulders out there on the horizon, Pete. Shoot me.
As Conrad and Bean began preparations for their first trip of exploration, men on Earth began their attempts to fix their exact landing site. They were aided by Dick Gordon, orbiting in Yankee Clipper.
I have him tripping. Well done, Clipper.
Dick Gordon using the 28 power sextant for these sightings.
I see Surveyor. Roger, Clipper. Good eyeball. Well done.
A major goal of Apollo 12 had been accomplished. For before men can engage in meaningful lunar exploration, they must be able to select a precise site and get there.
The first task performed on the moon was a thorough check of the lunar module in preparation for a possible early liftoff. About 3 hours after touchdown, Conrad and Bean donned their portable life support systems and prepared for the first period of work on the moon's surface. Commander Conrad left the lunar module first. As he descended, he opened the equipment bay, exposing a television camera which transmitted the first color television from the moon.
Al was very kind and took my picture on the way out, and this was our first look at the surveyor's site.
I'll head it down ladder. Okay, wait, let's put you on the camera. Okay. And is that a pretty looking sight, that limb? You're coming into the picture now, Pete. Okay. Okay, got the old camera on it. Okay. Down to the pin. Okay. Man, that may have been a small one for Neil, but that's a long one for me.
At 6:44 a.m., Conrad stepped from the lunar module and became the third man in history to stand upon the lunar surface.
Yeah, I guess this is the first time that Pete got out, and he's getting ready to move over here to the right. One of the interesting things is to watch the way Pete moves. This is pretty much the way it looked, too. Watch how slowly and carefully he moves when he first gets out, and you feel like you're slightly unbalanced. And before the movie gets much further, you'll see that you catch on real rapidly and you quit moving so slowly and start to jump around on the lunar surface. But right now you're trying to find where your CG is. Look how far forward Pete looks.
He first evaluated his ability to move about.
Well, I can walk pretty well. Now, but I gotta take it easy and watch what I'm doing.
Yeah, this is a quick break off the flight plan. I couldn't stand it any longer. I had to go see if I could see the surveyor.
Real surveyor, yes, sir. Does that look neat? It can't be any further than 600 feet from here. How about that? Well planned, Pete. Got a little chore to do here, right? Say again? I say that was well planned, Pete. Yeah, just a couple of months with a lot of people. Let's see, deploy the LEC and the mesa that's done. I'm looking at my mobility. DG shift.
Now, Pete Conrad collected a preliminary geological sample.
Several small rocks sitting out in front of me that have deep.
Okay, here's Pete walking around again. He's getting ready to go get his contingency sample. He still looks, when you look out the window, he looks like he's tilted way forward. The lunar surface didn't look quite this dark to us. It looked this dark when we got the dirt inside and looked at it, but when you look out the window with that bright sun, it's more like the color up in the upper left-hand corner, or even lighter.
Well, let me, I'm going over to get my contingency sample, and I'll get one of the rocks in the sample. And, yeah, as a matter of fact, it is built up on the side that the limb landed on. Let me get it. Oh, there's one scoop. There's another with some more rocks in it.
One of the more unusual and different rocks that we brought back was picked up in that contingency sample, and you can see the rock right to the extreme right in the movie, and I'll go over and get it in just a minute. It had all the appearances of good old American concrete when we got it back, and that first time they showed me the picture, I said, "Who put the rock of concrete in there?" And they said, "No, it's a very different one," and it was picked up right there, sitting right next to the LEM.
I think that's about enough, don't you? If there's one big rock you're pretty to pass up. No, I think that'd be a hog. Won't fit. Go over here and get this other one. Oh, you sure lean forward. Hey, lean forward. I feel like I'm going to fall over in any direction. They're leaning about. Hey, Houston, one of the first things that I can see, my golly, is little glass feet. I got a piece about 1/4 of an inch in sight. I'm going to put it in a contingency sample bag. I can get it. I got it. Am I really leaning over now? Sure are you. I know if you fall over, I believe. Huh? On Earth, you fall over leaning that far forward. But it's a little weird, I'll tell you. I don't think you're going to steam around here quite as fast.
I think the point that Al's going to make, I turned around and walked back here, and I was still trying to walk like you do on Earth. And that's just not the way to go. Also, if you watch carefully, you can see the dust fly. Your feet always had a little dust cloud with them whenever you were moving. We've got some other... Yeah, that's just not the way to walk.
Hey, Houston? Al, verify feed water's on. I'm about to fall down this little crater hole. Oops. Wait, he really does put... I gotta get over here in the shadow. I'm down in a... Whoops, another crater hole. There's a regular obstacle course over there. Man, am I gonna get dirty. Hold it now. Back up a little ways.
This is our first
No
transfer.
trouble at all.
This was the 2 LIOH canisters and the 2 batteries that were going up for the to use to recharge the bliss for the second EVA. Now we're beginning to get the hang of it. You hop.
You find that it's difficult to see where your CG is with all the backpack on and the low gravity. So you quit worrying about it and you just keep moving a little bit like a boxer does in the ring. And you don't worry about your CG. And I guess as you start to lean either way a little bit, well, you just dance over that direction and you keep your feet under you.
This is our first transfer.
No trouble at all.
Pete, you're 34 minutes into the EVA and you're right on the nominal timeline.
And you'll see us bring the bag back down, and that was taking the 70mm cameras to the lunar surface. Now I'm beginning to get even more of the hang of it. Well, it only took about 10 minutes to figure out. See a little dust cloud that goes with you wherever you go. You can you throw dust about 2-3 feet every time you walk.
Okay, let her go. That's it. All right, now just hold it right there. Hold it, hold it, hold it.
Alan Bean began his descent to the lunar surface.
I'd go back and re-salvage it if you want to take it.
This is Al coming down the ladder.
Press on with what you're doing there, Pete, and we'll get a answer back to you. Okay. And Pete, press on. No problem. Okay. Attaboy. Okay. You look great. Welcome aboard.
In moving the television camera from the lunar module to a distant point, the camera is believed to have been inadvertently pointed toward the sun, damaging the Vidicon tube. Several unsuccessful attempts were made to restore transmission.
Okay, Houston, I'm going to move the TV camera now.
And there's the ding-a-ling TV camera.
What apparently happened with the TV camera is I picked the thing off the mesa and set it down. The mesa was in the sun at the time, and when I set it down on this tripod right here, I apparently either pointed it at the sun or pointed it at the mesa, which was in the sun. It's pretty bright, reflective mylar and Kapton. And just that few seconds, which I guess was about 10 or 15 seconds, was enough to sunburn the camera, at least the upper half of the tube. And then that did it in right there. It's a real shame because a lot of people worked hard and long to get that color TV camera on the moon. And it's just a sensitive instrument. I know I didn't realize it was as sensitive to light as it is. And that did it. It was never to be recovered again.
The flag of the United States of America was implanted on the moon.
Pete, go ahead. Okay. Yeah, we have the flag up. Like I said, I hope everybody down there is proud of it. If we are to put it up. That's affirmative, Pete, and we're proud of what you're doing.
And the solar wind experiment deployed. The aluminum foil was designed to capture particles emitted by the sun and was retrieved prior to leaving the lunar surface. The exterior of the lunar module was thoroughly inspected, and the depth of the footpads was photographed. The Apollo lunar surface experiments package was then offloaded from the storage bay. A capsule containing radioactive plutonium was removed with some difficulty from its container. The nuclear-powered thermoelectric generator will produce 63 watts of electricity for over 2 years and is the first nuclear power plant used on the moon.
Okay. And we'll offload the outstep, I guess. No. We ought to be able to move out with this thing.
The 50-pound experiment package, which weighed about 300 pounds on Earth, was carried approximately 200 yards from the spacecraft.
They moved to the site selected to set up the station.
Hey, there's another one of those mounds over there. Where? Hey, you're right. What do you suppose they are? I don't know. It looks like a small volcano.
They put together the experiment station.
How far do you estimate we're from the lamp? 600 feet? 700 feet?
The 6 experiments were deployed at this distance around the central communications station so that the instruments would not be damaged during liftoff from the moon.
Piece by piece, they assembled the station.
Okay. I've got the solar wind deployed here.
A solar wind spectrometer was set up to monitor the interaction of solar wind particles with the moon. A passive seismic experiment was deployed to measure meteoroid impacts and moonquakes. A magnetometer measures any changes in the magnetic field on the moon. An ion detector measures the number of positive ions near the lunar surface. An ion gauge measures minute changes in lunar atmosphere density.
And the data station to collect the experimental measurements and transmit them to Earth.
The 6th experiment, mounted on the central station, measures dust collection on the experiments.
With ALSEP deployed, Conrad and Bean began collecting geological samples.
Oh, God. Oh, there's just rock. Look at that. Son of a gun. They gotta have that.
A core tube was inserted into the lunar surface to obtain a sample of the top 16 inches of soil.
Okay, I'm core tubing it right now. Kill. Auger it a bit and pound it. But now it's full length.
We show you're 3 hours and 7 minutes into it, into the EVA. And we'd like you back to the LEM to start the closeout in 10 minutes. That's at 3 + 1/7.
Had to smoke to get back to that LEM. We're a long way. Yeah, Houston, we're approaching the ALSAP. Headed back to the LEM.
Pete and Al, we're picking up your heavy footprints going by the seismometer.
The astronauts returned to the lunar module after working 4 hours and 6 minutes on the lunar surface to begin a rest period.
Okay, and then we ought to dust each other off. Man, we are filthy. Okay, coming up the ladder. Gosh, you're shaking the whole room. Sorry about that.
During the time the two explorers worked on the moon, astronaut Gordon was busy in the command module, performing multispectral photography, plus photographing desirable targets of opportunity.
Yankee Clipper, Houston. Hello, yes, Clipper here. Clipper, you were sort of the forgotten man for a little while. We're all eyes are on you now. We're with you.